In the recent Google I/O conference, Google DeepMind is making waves with their newest project Gemini, a large language model expected to compete with OpenAI's GPT-4 chatbot.
Gemini was created from the ground up to be multimodal, highly efficient at tool and API integrations, and built to enable future innovations like memory and planning.
We all know about PaLM 2, which was released in April 2022, their latest large language model, which is already enhancing 25 of Google's products, including the popular chatbot Bard. Moreover, PaLM 2's capabilities span across more than 100 languages and can even write code. This isn't surprising given Bard's recent edition of programming assistance was powered by this technology. During the demo, the AI was proficient in identifying errors in a code block and even adding Korean comments to each line. Okay, so now that's enough about PaLM 2. Let's talk about what to expect with the release of Gemini. Together with DeepMind, Google Brain is said to be developing a large language model that will have trillion parameters like GPT-4. The project is said to be using tens of thousands of Google's TPU AI chips for training, meaning it will take a while to have them all ready. So now I'd like to direct your attention to the screenshot from Google, which will basically tell us everything we need to know about Gemini. So this reads, we're already at work on Gemini, our next model created from the ground up to be multimodal, highly efficient at tool and API integrations, and built to enable future innovations like memory and planning. Gemini is still in training, but is already exhibiting multimodal capabilities like never before seen in prior models. Once fine-tuned and rigorously tested for safety, Gemini will be available at various sizes and capabilities, just like PaLM 2. So we already know that PaLM 2 large language model includes a range of submodels, some small enough that they can run offline on a mobile phone, to the larger ones that run in the cloud. Google's PaLM 2 model absolutely crushes GPT-4 in usability and application, all thanks to their Gecko submodel, which works even offline. So it's safe to assume that from the screenshot we just read, this new model that's expected to be released sometime in the future might just be the next GPT-4 rival in the form of a chatbot similar to ChatGPT. So one of the ways that Gemini could completely crush ChatGPT is by the use of more tokens than GPT-4, and GPT-4 currently uses about 8,000 tokens due to commercial limitations. And for those of you who don't know the significance of tokens, let me give you a quick run through. Essentially, GPT-4 has an ongoing issue where if you ask it to write something with more than 1,000 words, it barely returns back 500 words and sometimes stops midway. But that's not an issue, you can ask it to continue. However, sometimes it keeps breaking up, and if you continue to ask to continue where you want it to go on, it forgets where to continue off of. But Gemini, on the other hand, might not have the same issue, because it will likely have a much more higher token window, allowing to remember and provide much more information based on user request, without breaks or forgetting what the user asked for. One distinct advantage that can make Gemini stand out is Google's significant edge due to their immense data resources. Google has digitized over 25 million books, and if you consider an average book to contain 100,000 words, this translates into 2.5 trillion words. Additionally, Google also owns the YouTube dataset with at least 800 million videos. The typical length of a YouTube video is about 11.7 minutes. With an assumed rate of 100 words spoken per minute, this gives an average of around 1,170 words per video. This computes to an estimated 936 billion words in transcribed text. Google already mines data from the internet for its search engine capabilities. The volume of the internet dataset is colossal. According to one source, the Google search index is 100 petabytes as a minimum estimate. We can make a conservative assumption that after refining this dataset, it might be around the 2 trillion range. This estimation, even if conservative considering the vastness of the internet dataset, suggests that Google could feasibly expand the training to 5 trillion tokens. This would make the training dataset 5 times larger than that of GPT-4, which is thought to have been trained on 1 trillion tokens. While we might not be able to utilize the fully trained system due to the high costs associated with such a powerful LLM, the parent system could transfer its knowledge to smaller, more economically viable systems. Now let's dive into how Gemini operates. Gemini introduces a groundbreaking architecture that combines two key components, a multimodal encoder and a multimodal decoder. The purpose of the encoder is to convert diverse forms of data into a shared language that the decoder can comprehend. Once the encoding process is complete, the decoder takes charge, producing outputs in various modalities, tailored to the encoded inputs and the task given at hand. For instance, suppose we have an image as the input and the objective is to generate a corresponding caption. In this scenario, the encoder analyzes the image, transforming it into a comprehensive vector that captures its distinctive features and underlying meaning. Subsequently, the decoder utilizes this encoder information to generate a textual output that effectively describes the content of the